Let's start the new topic, torque. But before that, what we have discussed in the above here is are related to rotational kinematics. So, in that theory, we had not considered the actual reason that why such kind of rotational motion occurs. But if we want to know about the reason for such kind of rotational motion, we have to consider rotational dynamics. And so, we are introducing a physical quantity that is torque in order to start the analysis in rotational dynamics. So now with the help of this physical quantity, the reason behind the rotational motion will be answered, and the force which is playing an important role in rotational kinematics, or we can say not rotational motion, that is linear motion. Similarly, torque plays an important role in rotational motion. So here the force and torque are, we can say that both the quantities are interrelated. First of all, we will start our discussion for torque acting on a particle. So it is one kind of force. So starting our new topic, so here we have to consider one particle and we will see the effect of torque. So here the particle P is shown. Its position with respect to origin O is given by the position vector. Is small r, that is nothing but OP vector. Here theta is the angle between the position vector and this line of action of force. So theta is the angle between the position vector r and force F. So, due to this angle, the particle need not necessarily be a particle of a rigid body, and with this now the vector product of R and F will give us the value of torque with respect to this origin. So the vector product of R and force F is given by this is the symbol of torque and it is read as tau is given by R cross F. So this is your equation number 1. Now as per the law of cross product, I can write down this simple tau is equal to R F sine theta. So with only the help of magnitude, I can write down this equation. If you look at this R sine theta, so can I write down this as Ry? That is the component of position vector in the perpendicular or we can say vertical direction, and hence I can write down equation 2 in the statement form of tau is equals to F into the perpendicular distance of line of action of force from the origin, means O. So this is one kind of representation, and I can also write the definition of torque in another way. The torque is the moment of force with respect to a given reference point. And so I can find out now its dimensional formula. So it is very easy to find out the dimensional formula of torque as the dimensional formula of R into the dimensional formula of force. We know that the dimensional formula of R, that is the position vector, so that is L1, and the dimensional formula of force is equals to mass into acceleration, that means kilogram into meter per second square, so that is m1 L1 T minus 2, and so the dimensional formula of torque is equals to m1 L2 and T minus 2, and if you want to write down its unit, then it is also very easy. The unit of position and the unit of force. So the unit of force was Newton into Newton per meter square or Newton per meter, and so by applying the unit of this position vector we can have the value of SI unit of torque is Newton into meter. So this dimensional formula and SI unit can be asked in 1 marks MCQ. And with this, our introduction part of torque is over, but some necessary care you should have to take to study about the system of torque. So the first precaution what you have to take is, according to the right hand screw rule, the direction of torque is perpendicular to the plane formed by R and F. The second one, the value of tau depends on the reference point O, and so in order to define the torque, the reference point must be denoted. Or the reference point must be mentioned. So this is the torque acting on a particle. Now we will see the torque acting on a system of particles, because here we have considered only a single particle. But now let us see the observation in which the torque is acting on the system. Here we will discuss the torque acting on a system of particles. So here first of all I am starting my discussion in this way. Here I will consider a system is made up of n particles and each particle of the system is experiencing the external force. See, I have used a word over here that is external force. So, why I have neglected the internal force in this particular case? Because if you consider the internal force acting on a particle is equal and opposite. So, suppose two forces are acting on a particle or two internal forces are acting on a system of a particle, then their resultant will be zero. Why? Because suppose F1 is acting on particle 1 and the force of particle number 2 is acting on the first particle. So both are having the equal and opposite values, and with this F1 plus F2 will be 0. Therefore resultant force is equals to 0, and due to this reason we have not considered the internal force. Now let's start our analysis by use of this external force. Here I will write my particles. Here their position vector, and here I will write the force acting on them. So for the particle P1, its position vector, and remember this position vector is with respect to the origin, means the center or reference point, which is necessary to mention, otherwise you cannot consider a torque. And suppose the force acting on particle P1 is F1 vector, for particle P2 position vector is R2 and the force acting on it is F2. If I further increase my assumption, so for the particle Pn, the position vector is Rn and the force which is acting on this particle is Fn. And so with this, the resultant torque acting on every particle of the system I am denoting it as tau vector. So that is equals to the torque on the first particle plus torque on the second particle plus so and so torque on the nth particle. So basically this resultant torque is the vector sum of the individual ones, and therefore I can write down the expanded equation of this as R1 cross F1 plus R2 cross F2 plus so and so Rn cross Fn. So this is the final equation from which we can find out the resultant torque of the system. And this equation in a simple form I can write down as summation over I is equals to 1 to n in the bracket Ri vector cross Fi vector. So any one equation you can use, and we have seen the effect of torque on a single particle as well as on a system of particle. But what will be the torque on the rigid body? So that is our next task.